Okay, before we move on to the next topic, we need to take a moment and talk about how we measure concentrations in science and biology. Now, there are two ways. The one that's sort of easier for most of us to wrap our head around is called a percentage concentration. Percentage means that it's out of 100 per cent. Cent is 100, like 100 pennies in a dollar. This means that we are looking at how the weight of a solute, the solute is the thing that's dissolved in the water, and then the solvent is the water in this case, could be something else, but just not in biology. And then the two together are called a solution. So a 10% solution means that we have 10 grams of something in 100 mils of water. So if this were sodium chloride, we would have 10 grams of sodium chloride in 100 mils of water. But if we also made a 10% solution of glucose, we would have 10 grams of glucose in 100 mils of water. Here's the thing though, sodium chloride is much smaller and weighs much less than glucose. So if we were to actually count the number of molecules that are in that 100 mils, we would have many more molecules of sodium chloride than we would of glucose, because it doesn't take as many glucose molecules to reach 10 grams as it does sodium chloride. Okay. Now, a more accurate way and a more favored way of measuring concentration in biology is to measure the moles per liter. And I am not talking about the cute little critters that dig holes in the ground or the little raised bits of skin that are darker than the rest of the skin. A mole in this case refers to a number of molecules. Specifically, it means that we are talking about 6.02 times 10 to the 23rd molecules. For those of you that are math phobes, what this means is that I have to move this decimal place over 23 times before I have the actual number that we're talking about. Now, why did we choose a number that was that huge? Well, basically, scientists, early chemists, calculated how many molecules of hydrogen it would take to reach 1 gram. Okay, hydrogen's the most basic element, so they chose that one. And their calculation said that 6.02 times 10 to the 23rd atoms of hydrogen fit in 1 gram. Therefore, this is what we're going to call a mole. And again, don't ask me how they came up with mole. Molecular, some form of that. Anyway, when we talk about a 1 molar solution, what we mean is that we have 1 mole of whatever solute we're talking about in a liter of water. Okay, now this is a liter, not 100 mils. The 100 mils is because it is a percentage. So a liter is otherwise considered our unit, volume unit in science. So, 1 molar solution of sodium chloride is going to have exactly the same number of molecules in it as a 1 molar solution of glucose. Doesn't matter that glucose is bigger or heavier. Here we are counting the number of molecules that are in that solution. If it's easier for you to wrap your head around this by thinking of it as a dozen, so instead of a mole is 6.02, it would be like a dozen. So if we had a dozener concentration of sodium chloride, that would mean we had a dozen molecules of sodium chloride in this liter of water. And if we had a dozener, I'm trying to play with molar here, concentration of solution of a dozener concentration of glucose, then it's also a dozen molecules of glucose in that water. Same number, weights can change.